Hi. Good day, everyone. My name is 3Bagain from Besed Math 3B, and I am here today to present to you my geometric model in partial fulfillment of the subject M115 or abstract algebra. Okay, the title of my geometric model is crystal symmetry and is based on the idea of snowflakes because someday I want to experience the real snow. And I hope or I know that someday I will be able to experience that. Okay, so just to review, okay, for review part, we have here the front and back elements. We have the ILYSOMED for the front or the elements for the front, and for the back we have 1, 4, 3, 6, 2, 5, and 7 and 8. And then if we rotate that, we will have the crystal symmetry for the back after rotating. So as we can see, I is symmetric to 1, and L is symmetric to 4, S is symmetric to 6, O is symmetric to 2, M is symmetric to 5, E is symmetric to 7, and D is symmetric to 8. Okay, so this one is the correct front and back after rotating elements. Okay, so now to review, we will be reviewing the front moves. Okay, I is do nothing, L is one turn to the left, Y is two turns to the left, S is three turns to the left, O is four turns to the left, M is five turns to the left, E is six turns to the left, and D seven turns to the left. And now we will be reviewing the moves of back after rotating. We have one as rotate to the right or flip to the right, and then rotate to the right, then one turn to the right is four, and then three after rotated, turn or two turns to the right. Six is three turns to the right after rotating. Two is four turns to the left after rotating, and then five we have three turns to the left after rotating, and then 7, we have two turns to the left after rotating. Then lastly, we have one turn to the left after rotated to the right. Okay, so now that we know what are the moves for back, front and back, we will now be having here all the possible moves for front and back. So now, for the front and back after rotating elements, for everything that for this project, as we can see for front, I will use epsilon, this one, and upsilon. So epsilon for turning or front moves. So we're just turning it to the left. And then upsilon if we are doing the moves at the back, which is rotate to the right and then one turn to the right or one turn to the or turns to the left. Okay, so we have here the moves and we will change it from front moves or from ILSYOMD to epsilon, and then from 1, 4, 3, 6, 2, 5, 7, 8 to upsilon. Okay, so as we can see here, we have the epsilon for 1, 2, 3, 4, 5, 6, 7, 8, and then the next one we have upsilon for 1, 8, 7, 6, 5, 4, 3, and 2. So as we can see, we have front, epsilon, epsilon sub 0 is equal to I, epsilon 1, sub 1 is equal to L, epsilon sub 2 is equal to Y, epsilon sub 3 is equal to S, epsilon sub 4 is equal to O, epsilon sub 5 is equal to M, epsilon sub 6 is equal to E, and epsilon sub 7 is equal to D. Okay, so instead of using ILYSOMED, we will be using the epsilon from sub 0 to sub 7. And for the back, after rotating, we will be using the upsilon. As we can see, we have here the upsilon 1 or upsilon sub 1 for 1, and then epsilon sub 2 for 4, epsilon sub 3 for 3, epsilon sub 4 for 6, epsilon sub 5 for 2, epsilon sub 6 for 5, epsilon sub 7 for 7, and epsilon sub 8 for 8 itself. So we have here the moves. And now we will be doing the front or the epsilon. So as we can see, we have here do nothing because epsilon sub 0 is equal to 1, 2, 3, 4, 5, 6, 7, 8, which is this one would be this, the original, and then the number at the what do you call, below it is for the result. So as we can see, if we are doing nothing, or for epsilon sub 0, original and result will still be the same because we are not doing anything. So that would be it. And then we have here the epsilon sub 1. We have one turn to the left. So the original is this one, which is this, the number at the top. And then the result will be like this because we turn it one turn to the left. So it will move downward or to the left down. So as we can see, the 1 will be 2 here, and then the 2 will be 3, and then the 3 will be 4, and then the 4 will be 5, the 5 will be 6, the 6 will be 7, and 7 will be 8, and the 8 will be 1, as we can see. 1. Okay, and then let's check what would be the moves for epsilon sub 2. We have here the original, and then let's check the result. We will be turning twice to the left. Okay, so from 1, 2, and 3. So it will be 3 here. So 1 is 3, 2 is 4, 3 is 5, 4 is 6, 5 is 7, 6 is 8, 7 is 1, and 8 is 2. Because after we reach the 8, we will be returning to the 1 and then the 2. Okay, so that is the epsilon sub 2. Now will be looking or checking what is the movement for epsilon sub 3. We have here the original and the result. So for us to see what will be the result, we will be doing 3 turns to the left. As we can see, this one, so 1, 2, 3, and 4. So this one is 4. As we can see, 1 is 4, 2 is 5, 3 is 6, 4 is 7, 5 is 8, 6 is 1, 7, 2, and 8 is 3. 8, 3, 1, 4. So that's correct. So now let's check what is the move for epsilon sub 4. So as we can see, this one moved 4 turns to the left. Okay, so 1, 2, 3, 4. Is that right? I think. Okay, 1, 2, 3, 4. Or 1, 2, 3, 4, 5. That would be it. So that would be the 4 turns to the left. So as we can see now, we have 1 as 5, 2 as 6, 3 as 7, 4 as 8, 5 as 1, 6 as 2, 7 is 3, and 8 is 4. So that is the movement for A sub 4. Okay, now E sub 5, we have 1 as 6, so it will just go there. 6, 7, 8, 1, 2, 3, 4, and 5. So let's check for the E sub 6. We will be 6 turns to the left. So after 6 turns to the left, we will be seeing it 7 here, as we can see. Okay, as we can see, this one is 7. That is why 7, 8, 1, 2, 3, 4, 5, 6. 6 will be the last, which is the 8, as we can see here. So let's check what is the movement for the last one. We have the epsilon sub 7. We have 7 turns to the left. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. That is why we have the 1 as 8. So the 2 would be 1, the 3 would be 2, the 4 would be 3, 5 would be 4, 6 would be 5, 7 would be 6, and 8 would be 7. As we can see, 8 is 7. So those are the movements for the front. Okay, so those are the movements for front. So now let's check the movements, or what would be the, how would this elements would happen if we change the name from 1462578 into upsilon. Okay, let's check. So we have here the original, and this one would be the result. The same with the previous slides. We have here the original, and this one would be the result. So if we are rotating to the right for the epsilon 1, as we can see, we have the 1 as to 1, 2 as to 8, 3 as to 7, 4 as to 6, 5 as to 5, and then 6 as to 4, 7 as to 3, and then lastly we have 8 to 2. This one 8 and then 2. That is the movement if we rotate to the right, this one. From facing this original, we rotate it to the right and this will happen. Okay, so let's check the next one. So now, as we can see, it rotated to the right. I mean, it turned to the right, so it moved from here to the right. So after we rotate it to the right, so we still have the 1 8 7 6 5 4 3 2. Now we turn it to the right. So as we can see, we have the 1 now for 2, and then 1 8 7 6 5 4 3 3 and 8. Okay, let's check the next one. We have 2. 2 turns to the right. So if we turn it to the right, we have, as we can see, we have the 3 as the original, or for the 1. That's why 1, 3, 2 is 2, 3 is 1, 4 is 8, 5 is 7, 6 is 6, 7 is 5, and lastly we have 8 is 4. Okay, let's check the next one. Then, after rotating to the right, we have 3 turns to the right. Okay, 1, 2, and 3. So we have 4, 3, 4, 3, 2, 1, 8, 7, 6, and 5. Next, we have this one, the epsilon 5 or epsilon sub 5. We rotate it or we turn it 4 turns to the left. So 1, 2, 3, and 4. That's why we have here the 5. That's why 5, 4, 3, 2, 1, 8, 7, 6. Correct? So we will be doing the epsilon sub 6. So 6 is the number at the top, which is 41. As we can see, we rotated it 3 turns to the left. Okay, so from 1, we have 1, 1, wait. So 1, 2, and 3. Okay, that's why we have here the 6. 6, 5, 4, 3, 2, 1, 8, and 7. Next, let's check the epsilon sub 7. We have the 7 at the top. 6, 5, 4, 3, 2, 1, and 8. And then lastly, we have epsilon sub 8. We just turn it 1 turn to the left. Okay, so imagine that this one would be the 1. And then if we rotated it to the left, 1 turn to the left, as we can see. But as we can see, this one turn to the left, we have here the 1, and then this one is the 8. And then we rotate it to the left, we have here the 8. So 8, 7, 6, 5, 4, 3, 2, and 1. So those are the movements for everything. As we can see, here are the front and here are the back. From 0 to 7, from epsilon 1 to epsilon sub 8. Now that we know the permutation movements or the permutation moves of crystal symmetry for front and back, we will be now doing completing the table. Or we can see here the table of results after doing everything here. So here, as we can see, we have the letters or the movements from epsilon sub 0 to epsilon sub 7, from epsilon sub 1 to epsilon sub 8. So we will be doing or multiplying the E or epsilon sub 0 and epsilon sub 0. So what would be the movement? If we are doing nothing and times it to do nothing, the answer would be, as we can see, this one is the original. Okay, and then the result would be at the middle. Okay, I corrected it already. As we can see, this one is 6, 6. So what will be the answer? The answer would be 6 by 6. That's it. That's the answer. It will still be e sub 0 because anything that you multiply by e sub 0 will still be the same answer, or the result will still be the number that you are multiplying. That's why do nothing times do nothing is do nothing. That's why still e sub 0. Therefore, this shows that everything or anything you multiply with the identity, our identity here is e sub 0 or this one. So anything that you multiply with this identity or element will be equal to the element being multiplied. That's why e star e sub 0 star e sub 1 will still be e sub 1. E sub 0 star e sub 2 will still be e sub 2. E 0 or e sub 0 star e sub 3 will still be e sub 3. So it will be the same with all of this and all of this. That's why the first row and the first column will still be the same element with this or at the header or at the top. Okay, so the next one that we will be trying or multiplying would be e sub 1 and e sub 1, which is this one. Okay, that's what we are going to multiply. We have here the same number. We have 2, 3, 4, 5, 6, 7, 8, 1 and 2, 3, 4, 5, 6, 7, 8, 1 as the e sub 1. So what will be the answer if we multiply e sub 1 and e sub 1? As we can see, again, we have here the original, and this one at the lower number would be the result. So we will be looking at the first number, the e, or this second second permutation group. We have here the 1 and 2. So we will be looking at the 2. And the answer below the 2 would be the new 1. So as we can see, we have here the number 1, 3. So we'll be looking at the 2. We have 3. So we will be looking at 3. And the answer is 4. So 2 is now the 4. Now, let's check the 3 or the 4. We will be looking at the 5 here. So 5 is 6. That's why 5, I mean, the new 4 is 6. So we can see the new 4 is 6. Okay, let me just erase that one. So the new 4 is 6. So the next one we have here the 5. So we will be looking what is the new 5 now. So 6, we will be looking at 6, it's 7. So the new 5 is 7. So same with this one. 6, what is the new 6? We have here 7. So we'll be looking at 7. And the new 6 is 8, as we can see. And then 7, what would be the new 7? We'll be looking at the 8, and the new 7 for 8 here is 1. And that's it. We will be looking at the 8 here. It's 1. So 1 here is 2. That is why the new 8 is 2. So what is the answer, or what it is the number or the element that we have with the combination as like this one? We'll be looking here. Is it the e sub 2? Let's check. And yes, it's E sub 2 as we can see here. So the answer here is E sub 2. So that would be how we will be getting the next few answers. So here we have the epsilon sub 1 times or star epsilon sub 2. Okay, so we will be looking at the second or the right permutation group. We'll be looking at the 1 and 3. So first, again, remember the top part would be the original, or what we are going to find, what would be the next answer will be. And these ones would be the answer, especially this one. Okay, the first permutation group. So we will be looking at the 1, I'm so sorry about that one. So we'll be looking at the 1 and 3. So here at the permutation or the first permutation group, we will be looking at the 3 here, and the answer is 4. So the new one is 4. Okay, so that's how we got the answer. 1 is the new 4. And then let's check the others. We have 2. What would be the new 2? Let's look at the 4 here. 4 is 5. That is why the new 2 is 5. And then 3, we will be looking at the 5 here. So the new 5 is 6. So as we can see, the pattern is 4, 5, 6, 7, 8. And then if we reach the 8, we will just start again with the 1. 1, 2, 3. Okay? So that's how we get the answer, by looking at the top and finding the number at the lower number of that, and then checking it, and the answer will be at the lower of that number. Okay? So what would be the answer here? The answer is what? Okay, that's the answer. As we can see, we have epsilon sub 3 as the new E sub 1 star E sub 2. So that is how we get the answer for the rest of it. Okay, therefore, or looking at the pattern shown in the table, we can conclude that the elements are shifting one position at a time. That is why from E sub 1 to E sub 7, we're simply counting up to E sub 0. So as we can see, we're simply counting up to E sub 0 because E sub 7 would be the last number for epsilon. So the next one would be E sub 0. So E sub 1, 2, 3, 4, 5, 6, 7, and then we will be returning to E sub 0. So what would be the answer now if we try E sub 1 to star epsilon sub 1? Okay, so let's check what would be the answer. So here we're looking here. The first permutation group is the epsilon sub 1, and the second permutation group is the epsilon sub 1. So again, the number at the top would be the original, and then the number below would be the result. And now we will be looking at E or a 1 here, and then 1 here. So we're looking at the 1 here, and the answer is 2. So the new one is 2, right? And then 2 is 8, so we'll be looking at the 8. 8 is 1. So the new 2 is 1. Okay? And now looking at the 3, what is the new 3? We can see 7, so we will be looking at 7. So the new, as we can see, is 8. The new 3 is 8. So it goes on and on. So we have here the 4. What would be the new 4? As we can see, it's 6. So we will be looking here for 6. And the answer is 7. So 2187653, and that would be it. So what would be the combination here? Let's check what would be the answer. And the answer is 21876 and 43. So that is epsilon sub 2. Okay, so that would be the answer. E sub 1 star E U epsilon sub 1 is epsilon sub 2. So now that we know it's epsilon sub 2, the next ones with B, let's check. As we can see here, we will be multiplying this one, the epsilon sub 1 star epsilon sub 2. Okay, so let's check what will be the answer. Okay, so we are looking here at 1. So the new one is at the 2. So it's 3. Oops, what happened? So it's 2. Okay, I mean 3. It's 3. The new one is 3. As we can see, it's 3. And the next one, the 2. or the new 2 can be seen at the 1. So it's 2 here. And then 3 can be seen at 8. Here, 8. So it's 1. So 3, 2, 1. And then what do you think is the next answer? It's, what would be the new 4? It can be seen at 7. It's 8. Perfect. So 3, 2, 1, 8, 7, 5, I mean 7, 6, 5, 4. So what would be the element for that? We have this one, 3, 2, 1, 8, 7, 6, 5, and 4. So that would be upsilon sub 3. Perfect. So that would be the same with the next one. As we can see, it will be the same with everyone. That is why we know that the next one would be epsilon sub 4. Oh yeah, that's good. So it will be like that as we go forward. So this one would be epsilon sub 1 star epsilon sub 2 would be epsilon sub 5, and then epsilon sub 6, epsilon sub 7, epsilon sub 8, and then the last one would be epsilon sub 1. Okay, so as we can see, we're just shifting from one number to another as we go on. Okay, as we can see at the end of this lane or anything that we after doing everything at the epsilon sub 1, we can reach the last one, which is epsilon sub 1. So as we can see, from epsilon sub 2, 3, 4, 5, 6, 7, 8, and we reach the last number, we will be returning at the first number, which is the epsilon sub 1. Okay, then let's So now, as we can see, we have epsilon sub 2 and epsilon. This one is epsilon sub 2 and this one is epsilon sub 1. So if we want to get the epsilon sub 2 star epsilon sub 1, which is this intersection right here, we will be looking here. So the same with the other previous um, so again, to find the epsilon sub 2 star epsilon sub 1, we will be looking at this, the right permutation group, and looking at the first one, that would be the new number. So 1, 2, we will be looking at the 2. So the 2 can be seen here. Okay, I don't know why the red box is there. So it should be here. 2 is the new, or the new one would be 4. Okay, so the answer would be 4 here. And then what would be the new 2? 2 is 3. So we'll be looking at the 3. It's 5. And then for the 3, we have 3 star 4. We will be looking at 4, so it would be 6. And then the new 4, let's check. 4 is 5. So we'll be looking at the 5 and it's 7. So as we can see, it's already 4, 5, 6, 7, and 8. 1, 2, 3. Okay, let's check if that would be correct. We have here, yeah, so that would be correct. 4, 5, 6, 7, 8, 1, 2, 3. So what would be the element for that? What would be the name? It's epsilon sub 3. So yes, as we can see, it's epsilon sub 3 here. So that will be the answer for that. So let's check for the epsilon sub 2 star epsilon sub 2. So we have the same 3, 4, 5, 6, 7, 8, 1, 2, and 3, 4, 5, 6, 7, 8, 1, 2. So the same with the previous ones. We'll be looking at the 1 for 3. So the new 3 is 5, and so on and so forth. Let's check. As we can see here, 1 is 3 and 3 is 5, and so on and so forth. And the answer would be like this. So the new one is 5, the new 2, 4 is 6, 5, 6, 7, 8, 1, 2, 3, and 4. So the new answer, or the answer for epsilon sub 2 and epsilon sub 2 would be a sub 4. So now that we know that it will be just a sub 2, 3, epsilon sub 2, epsilon sub 3, epsilon sub 4. So the next one would be epsilon sub 5, epsilon sub 6, epsilon sub 7, and epsilon sub 1, and epsilon sub 0. Okay, so that's how this one goes on and on. So let's check if that would be the answer. Okay, so I'm correct. We have here E2, E3, E4, E5, E6, E7, E0, and E sub 1. Looking at the pattern shown in the table, we can conclude that the elements are shifting again from one position at a time. That is why from E sub 2 to E sub 7, we will just go back on counting to E sub 0 and then E sub 1. And now let's check what will be the answer for E sub 2 and epsilon sub 1. Here, epsilon sub 2 and epsilon sub 1. Looking at this, we know that this one would be the original and this one would be the result. So looking at the new one, 1, 1, we will be looking at the 1, and then the 1 is 3. So the new one is 3. Okay. 1 is 3, 3, 2, 1, 8, 7, 6, 5, 4. So what would be the element for that? We can see here that it is epsilon sub 3. So the epsilon sub 2 star epsilon sub 2 star epsilon sub 1 would be epsilon sub 3. So now that we know that, let's check the next one. We have epsilon sub 2, and epsilon sub 2, what would be the answer? So we know that 1 or the new one would be can be seen at the 2 at the first permutation group, and it would be 4. So the new one would be 4. And what would be the answer for that? 1 is 4, 2 is 3, 3 is 2. So 4, 3, 2, 1, 8, 7, 6, 5. So what would be the answer for that? What is the element that has this number? It's epsilon sub 4. Okay, so as we can see, we have already the pattern. So epsilon sub 3, epsilon sub 4, epsilon sub 5, epsilon sub 6, epsilon sub 7, epsilon sub 8, and then we will go back to 1 and then 2. Okay, let's check if that would be the answer. And correct. So looking at the pattern again, we know that it's just shifting from one position to another, from the lowest to highest, and then it will go back to the first number again. Okay, so next, let's check. We have the epsilon sub 3. Okay, for epsilon sub 3, we have the original here and then the result here. So we will be looking at the new one. We have the new one is 5, as we can see. So let's check what would be the next numbers. 5, 6, 7, 8, and 1, 2, 3, 4. So it goes on and on. And as we can see, that epsilon sub 4 is the new answer for that. And that would be the next one would be epsilon sub 4, 5, 6, 7, 8. I mean 7, 0, 1, 2. And we will go back at 3. So that would be it. And then that's just like how we will just get the first number here, and we will know what would be the next answer. Okay, let's check. We have here 1, 1. So the new one is 4. So 4, 3, 2, 1, 8, 7, 6, 5. So if you know the first number here, you know what will be the next remaining numbers. So this one would be epsilon sub 4. So now that we know the epsilon sub 4, the next one would be 5, 6, 7, 8, 1, 2, and 3. Okay, let's check if I'm correct. It's correct. Okay, so that's how we do it. From 4, 5, 6, 7, 8, 1, 2, 3. So we know and we can see the pattern on how it happens. And next we have the epsilon sub 4 and epsilon sub 1. Again, we have here that, and we know that the new one would be 6. Okay, so we know the 6. So it will be just 6, 7, 8, and then you will go back to 1 up to 5. And what would be it? It's epsilon sub 5. So now that we know it's epsilon sub 5, from 4, 5, 6, 7, 0, 1, 2, and 3. Let's check if that's how it will be happening. Okay, I'm correct. So that's how we get the answer. So let's check what would it be if we multiply it to epsilon sub 1. So the new one would be 5, and 1, 5. Now that we know the 5, we'll just go downward from that. 5 4 3 2 1 8 7 6. The same, U5. So we know that after U5, it would just 6, 7, and 8, and then 1, 2, 3, up to 4. So the last number here should be 4, and it's correct. That's the pattern. Okay, now let's check the E sub 5. So that's how we will do it for the next remaining numbers. We know that the new one is 7, and let's check if it's E sub 6. Okay, so I think this one has, I forget to put the correct answer here. So the correct answer should be, as we can see, we have the 1, 2. So we'll be looking at the 2, so it should be 7. 7. We'll be looking at 3. 3 is 8. And then 3, 3, 4, it would be 1. So 7, 8, 1, 2, 3, 4, 5, 6. So as we can see, that would be the epsilon sub 6, as we can see here. So that is why the answer is epsilon sub 6. Okay, so from epsilon sub 6, it will just be 6, 7, 8, 9. I mean 6, 7, 8, 1, 0, 1, 2, 3, 4, 5, or up until 4. Okay, that is the pattern. So let's check what would be the answer for the epsilon sub 5 again. So I think that this one would be the correct one that I had mistake earlier. Mhm. So it's 6 5 40 to 187 6 3. Let's check what is that. The 6. So let's check. 1 is to 1. So the new one is 6. Correct. 2 is 8. 8 is 5. 6 5. So I think the answer here would be epsilon sub 6. So this one, it should be epsilon. Okay, it's not E. Okay, it should be epsilon sub 1. Okay, epsilon's 5 star epsilon sub 1. The answer would be equal to epsilon sub 6. Okay, and then now that we know the answer, it will still be the same from there to the next one. Okay, so now that we know how to do it, if we know the first number here, we will know up until the last. The same with this one. If we know the first number here, we will know the rest of the numbers. So looking at this, we have the completed or the table of result. Okay. Gano'n naman to kasakit? Gano'n naman yan kasakit? 33 minutes ka nang nagsasalita. Okay. Hello? Okay. So, my laptop was lagged for a bit. So now this one would be the table of result or the completed table of result after doing all of the permutation of the crystal symmetry. Okay, so now that we know the table of results or the completed table, to conclude that this permutation table of result or this table also forms a group under permutation multiplication with the 16 symmetries from the geometric model I have constructed. The following conditions must be satisfied. Okay, so now that we know or we can see here the completed table of this or the completed permutation table, what we need to do next is to check if this will be or this can form a group. Okay, if this one or this permutation table also forms a group under permutation multiplication. So we can say that this table can be a group if it's close, if it's associative, has an identity element, and has inverse element for all. So as we can see, the conditions, the close. First condition, is it close? Since the resulting element were just found in the set, so we know that the set or the name of this or the elements on this set would be E sub O, E sub 1, E sub 2, E sub 3, E sub 4, E sub 5, E sub 6, E sub 7, epsilon 1, epsilon 2, epsilon 3, epsilon sub 4, epsilon sub 5, epsilon sub 6, epsilon sub 7, epsilon sub 8 can be seen only from all of these resulting elements that we did by multiplying two elements, and there are no outside elements that can be seen here. So therefore the permutation table is closed. So yep, that is check. Now let's check the next condition. Second condition, is it associative? Okay, to confirm that the permutation table is associative, we must flip it by 180 degrees. The flip table must be the same as the arrangement of the resulting elements, or this one. So as we can see, after we flipped it for 180 degrees, we cannot understand it. That's why we need to make it this way. Okay, now that we know, let's check if the second condition, is it associative, is true. But before that, we have to change some rows. Okay, so the first thing that we need to do is interchange row epsilon sub 7 to epsilon sub 1. So as we can see, we have here epsilon sub 0, epsilon sub 7. So the next number should be epsilon sub 1. That's why from this one we should put it here. Okay, and then interchange row of epsilon sub 6 to epsilon sub 2, so that the next one, as we can see here, it's 6, it should be 2. So this blue should be interchanged, this yellow should be interchanged, and this brown should be interchanged. The same with this one. The V7 or the epsilon sub 7, I'm sorry, and epsilon sub 1 should be interchanged, so that the epsilon sub 1 should be here at the top. And the same one with this one, epsilon sub 2 and epsilon sub 6 should be here at the epsilon sub 6, the 2. And so the pink and the brown and the violet should be interchanged as well for us to be able to get this, the table after interchanging some rows. Okay, as we can see, epsilon sub 0 to 7, epsilon sub 1 to 8, and we know that we got the original table. So we have the same answer to here and to here. So by inserting and interchanging rows, the resulting elements in the flip table can be arranged like on the original permutation table. So this means that it is associative. So yep, that is check. So now the next one would be, does identity element exist? Okay, so since there's an intersection of the row on the tables that was the same as the order of the elements on the outline, so as this one, outlines of the table, then there exists identity element that is epsilon sub zero. Yep, so we know that it's just resulting the same elements if we are multiplying it to epsilon sub zero. So it means it has an identity element which is epsilon sub zero. So yep, that is check. And the last one that we need to check, or the condition, the last condition that should be satisfied, should be or is has inverse element for all. So fourth condition, does inverse element for all exist? Since there exists identity element for every row, that is e sub 0, we know that there is an inverse element for everything. So the inverse element for e sub 0 is e sub 0. The inverse element of e sub 1 is e sub 7. And the inverse element of e sub 2 is, as we can see here, e sub 4 here. Okay, I mean e sub 6, sorry, e sub 6. It's 6. I thought it was 4. And then this one, the e sub 3 or the epsilon sub 3, the inverse of it is e sub 5, as we can see. And then e sub 4 is e sub 4. E sub, what do you call this one? 5 is e sub 3. And e sub 6 is e sub 2. And e sub 7 is e sub 1. Okay, those are the inverse element of this identity or these elements. So anything where is the inters or the two elements has the intersection of e sub 0, that would be the inverse element of those two. As we can see here, the epsilon sub 1, the inverse element is epsilon sub 1 as well. And the same with epsilon sub 2, it's 2, epsilon sub 3 is 3, epsilon sub 4 is epsilon sub 4, and so on and so forth. Therefore, we know that it has an inverse element for all because all of the elements have inverse element each. Okay, so it's check as well. Therefore, we know that this permutation table also forms a group under permutation multiplication with 16 symmetries from the geometric model entitled crystal symmetry, as we can see here, because the following conditions are satisfied. It is closed. Yep, because all of the elements are within the set that we have given. And next, it is associative because after flipping the table 180 degrees and interchanging some rows, we got or it resulted to the original table. And correct, it has an identity element e sub 0. And last one, it has inverse element for all because e sub 0 can be seen all throughout this table. And that's it. That would be my crystal symmetry for project number 5. Thank you so much for listening. Have a great day. Bye.